Hello everyone. Yeah, hi Mukesh. I think I'm audible, guys. Let me know in the chat if you can hear me. Yes, good evening everyone. I hope I'm audible and I'm visible, guys, to all of you. Let me know. So we'll wait one more minute, guys, then we can start the session. Yeah, so let's wait one more minute, then we can start the session with our agenda for today. So today we're going to discuss like data drift detection with the help of evidently the MLOPs tool, and we'll try to complete the data validation component as well. Okay, in this particular session today. Hi, sir. Please go slow because onwards new topic for us today. See, actually, the thing is like you are learning end-to-end implementation here. So for this, you need some basic prerequisite, as I already discussed in my first session. So please try to complete that particular prerequisite first of all. Then it would be easy for you to understand. Okay, otherwise things would be much complicated for you, right? Again, I'm going slow because it's a live session I'm taking. After that, the recording is also available in my YouTube channel. So if you're not getting something in the live session, what you can do, you can still watch that particular recording and you can sort out your issue. Okay, so that's how actually you can complete. You can revise that particular video again. Okay, this will give you the clear cut idea. But again, your prerequisite should be ready. Otherwise, some difficulty you will face, right? Okay. So now I think we can start the session, guys. So first of all, let me write down the agenda, like what we are gonna cover in this particular session. So I have opened my Blackboard. Just a minute. I think my pen is not connected. Just a minute. Okay, now I think it is fine. So today is, I think, day 6. And today's discussion would be data drift, demo with evidently. Then the next thing will be covering the data validation part. Okay, data validation part. I'll tell you what are the things you have to do in the data validation. Okay, I'll show you that particular like diagram. With the help of particular diagram, you can understand what you have to do inside data validation. But before starting with the data validation, first of all, let's complete this particular data drift detection with the help of evidently, because this particular technique we're going to apply inside our data validation. Okay, so what exactly this validation means? You want to validate your data. Let's say here I am having my data, so you can see this is my data. So if I open up my data, so it is having some of the features. You can see it is having some of the features. Let's say it is having continent, education of employee, case ID, has job experience or not. So these are the features actually. So what will happen actually? Let's say if I want to train this particular data, so what I have to do? If I want to train this particular data, what I have to do? I have to first of all take that particular training data. Then I will be giving to my model. Okay, but let's say there is a possibility your data may change. Okay, let's say after data ingestion your data may change. Let's say one specific column is missing. Let's say one column is missing. Okay, one column is missing in your data. Now if I give this particular data to my model, will it work? So definitely it is not going to work because one column is missing here. Okay, one column is missing here. Or let's say you have trained your model, with the help of training data. Okay, with the help of training data. Now during testing, you got a completely new data set. Okay, that particular data set doesn't have any kinds of columns. The columns actually you can see here. So that time actually your model will fail. Your model will give you error like this particular entity is not available. So that's why first of all, before training that particular model, I just need to validate the data whether my data is in correct format or not. That means what I have to do, I have to check whether these are the columns are available or not inside my data. These are the features are available or not inside my data. If it is available, okay, if it is available, then I will return one statement. I'll return one statement like validation status is true. Like my data is in correct format. So there is no issue with my data. That's why this particular validation, okay, validation status, it would be is equal to true. Otherwise, what I have to do, I have to make it as false. And whenever it is false, I'll break my code there. I'll break a code there and I will raise an exception. Okay, I'll raise an exception. I'll tell the user your data set is not in a correct format. So please try to fix your data first of all, then try to train the model. This is the idea. So that's why before training our data, okay, before training our data, first of all, we have to validate that particular data, whether this particular data set is in a correct format or not. I have to validate that particular schema. Okay, so this is one level verification. We'll be doing multi-level verification here. I'll tell you what are the things we're gonna do. So, but before that, first of all, let's try to understand the data drift, like what exactly it is data drift and why we face this particular data drift problem inside our let's say machine learning. Okay, first of all, let's try to understand this particular data drift. If you are completely new to this particular data drift, if you don't know about data drift, first of all, let's try to understand the data drift. Then I will show you one practical demo. Okay, how we can detect the data drift. So to explain the data drift, guys, here what I can do, I can take actually two distribution. Let's say this is my training data. I think I can take small size. Yeah, so this is my training data. Okay, training data. So training data distribution looks like that. Let's say this is my training data distribution. Okay, this is my training data distribution. All right, now there is another data I'm having called test data. Okay, now let's also plot the testing data distribution. Let's say it will look like that. Now guys, please tell me whether this particular distribution is matching or not. This training data distribution and testing data distribution is matching or not. Yes or no? Is it matching? I think no, it's not matching, because you can see training data having a completely new distribution and testing data is having completely another new distribution. That means this particular distribution is not matching. Okay, but what we have learned inside statistics, I think you remember, this is a statistical concept. So I think you know, in statistics actually we are having something called population. Yes or no? In statistics we are having something called population. Maybe you have learned this particular population concept. Now if I take something from the population, this would be considered as my sample. Okay, let's say I have taken some of the sample from the population. It would be considered as my sample. Okay, now if you plot this particular sample, let's say this is my distribution of the sample, and I also plotted my population. Again, this is the distribution of my population. Now most of the time you will see this particular distribution and this particular distribution will be same. Why? Because this is the statistical concept. They are telling, if you are taking something from the population, as a sample, so that particular sample distribution will be same as per your population distribution, because the same data you are picking from the population. Okay, so that is the idea. But here you can see whether I have taken my data from my training example, because what I have done, let's say first of all I have done, let's say first of all I had one data. Let's say I have one main.csv data. what I did the 10 test speed. So after doing the 10 test speed, I got my training data, I got my testing data. Then what I did, I just plotted this particular data over the graph, and I can see this is the training distribution and this is the testing distribution. And I can see that this particular distribution and this particular distribution is not same. It is different. That time, this is a problem of data drift. That means this particular training distribution and testing distribution is not matching. Whether you have taken your data from the, let's say, population. Okay. You have taken your data from the population, but still your sample data is not matching with the population distribution. Okay. So this is the problem of data drift. Data drift. Okay. And this is like one of the very, what I can say, very actually, very much complex problem inside machine learning. So if you get data drift problem, so your accuracy would be like very lower there. Okay. Yeah. How, let's say I will give you another example. Yeah. I'll give you another example. Actually, let's say you are working with computer vision. Okay. Let's say you are working with computer vision. So there you have trained your model with the help of dog data set. So this is my model. What you have done, you have trained a data model with the help of dog data set. And if I plot this particular dog data, let's say this is the distribution of the dog. This is the distribution of the dog. Okay. Now, whenever you are testing the model, okay, whenever you are testing the model, that time you are giving the cat images to this particular model. And let's say cat distribution look like that. Okay, this is the cat distribution. Now tell me, whenever your model got trained, did your model saw this kinds of distribution or this kinds of distribution? Tell me. This is my first distribution, this is my second distribution. Your model saw this particular first distribution. This kinds of second distribution, it didn't see, right? So that's why whenever you are giving this particular cat image during testing, you will see your model will performing wrong. Okay, there would be a false output always. Okay, there would be a false output always from the model, right? So this is actually again a data drift problem. Data drift problem. Okay, data drift problem. Because again, your sample is not matching with your population distribution. Okay, so this is a data drift problem. I hope you got your answer, right? What is exactly this data drift? So what I have to achieve, guys, always I have to achieve whenever I'm having some population. Let's say when I'm having some population, let's say I'm having main.csv data. This is my complete data. After doing the 10 test speed, what I will get my training set as well as my testing set. Okay. And whenever plot this particular training set, so this distribution, and whenever I'll plot my testing set, this distribution will be same. Okay, it should same always. Okay, that time I can consider it's not a data drift problem. Okay, data drift problem. So we have to achieve this particular output always. Okay, we have to achieve this particular output. If there is a data drift problem, again you have to fix your data. You have to tell that particular user, okay, or let's say you have to tell that particular developer, there are some issue with your data, with your sample data. So please try to fix your data first, then try to train that particular model. Okay, this is the idea. That's why actually there are so many MLOps tool over the market. Because see, if you don't have the MLOps tool, what do you have to do? You have to manually write this particular code to detect the data drift. Okay, what do you have to do? You have to manually use, let's say, Seaborn, Matplotlib. You have to plot the distribution. You have to get that particular value. Then again, you have to write some manual logic. Then you can detect that particular data drift, whether my training distribution and testing distribution are same or not. If this is the same, there is no data drift problem. Otherwise, there is a data drift problem. Okay, based on that, you will make a decision whether your data validation stage would be true or false. If there is a data drift, again the data validation status should be false. Okay, and if there is not a data drift, this particular status should be true. This is the main idea. What will happen if we create the model with data drift data? I told you now. So let's say this is the example I showed you, right? let's say you are training one model with the help of dog images, but whenever you are giving the cat images, that time actually you will get a false output. Okay, it won't be giving you the correct output. It would be more robust on the dog side, not a cat side actually. Okay, I think you got your answer. How to solve data dip? What is the solution? So for this, again, you have to resample your data. Okay, again, you have to resample your data, and you have to make sure that particular data is also matching with your population distribution. Otherwise, again, you have to collect the data. Again, you have to increase the data side, okay, inside your database. That is the idea. So it will happen most of the time whenever you are having less amount of data. Okay, whenever you are having less amount of data, that time if you do 10 test split operation, you will see that in the testing data, you will have some of the data which is like very new. This is not available inside your population, which is not available inside your trained model. Okay, that is the issue actually we'll be facing. But whenever you are taking larger amount of data, this particular problem you won't be facing. Okay, so I'll show you one practical demo. It would be much clear, like how we can visualize this particular training distribution as well as the testing distribution, and how we can detect this particular data dip, okay, for all the columns we are having here in this particular data set. Okay, I hope this part is clear, guys. As a theoretical high level understanding, I hope you got like what is data dip exactly. Let me know, guys, if it is clear. So give me a like thumbs up, give me any kinds of emoji in the chat so that I can get to know this part is clear to all of you. Let me know, guys, if it is clear to all of you, the data dip, what exactly it is data dip. So train and testing data should follow the same distribution. Yes, Arashu, you're right. Because this is the statistical concept. Okay, in statistics, I think if you learn is the statistics, I think you know. Whenever I pick something from the population as a sample, that particular sample distribution would be same as per your population distribution. That is the idea. Just a minute. All right, so now how we can detect this particular data drift with the help of MLOPs tool, with the help of Python. Now let's try to see one demo. So what I can do, I can go back to my code editor, and I think you remember we created one notebook folder. Inside that, I'm going to create another notebook. So let's create this particular notebook. I'm going to name it as data. Okay, data underscore drift underscore demo. Okay, with evidently dot ip ynb file. Okay, this is the ynb file. That means Jupyter notebook file. Now let me create this particular file, and inside that I'm going to select my kernel, the kernel I've created called visa kernel. Okay, now if I want to test it, so I just write a print statement in this particular kernel. It should give me the output. That means this is working fine. Okay, this is working fine. Now see, I think you remember we already installed this particular evidently inside our environment. In the requirement.txt, I mentioned this particular evidently. You can see, so evidently package we have already installed. So the version was 0.2.8. So this was the specific version actually I was using. Now you can check the official website of the evidently. So if I just search evidently AI, so this is the official website. You can see this is the official website. And there is another thing actually we'll get called official GitHub. So evidently GitHub. Okay, so it is also available, and this is like very active resource. You can see the last commit was 2 days ago. This is the official evidently GitHub. You can see, okay, they have already given the distribution and all. They have already given the demo. Okay, you can see they have already given the example demo, how your data distribution will look like, and everything they have given. So here you can create a completely dashboard. So this particular dashboard you can create interactive dashboard. With the help of this particular dashboard, you can understand, okay, about your data dip. So not only data dip, with the help of that, you can do lots of things. You can monitor your dashboard. Then you can see, I think they have written here different you can generate the reports. Then what you can do, in the website, I think they have mentioned collab. evidently, evaluate, test, and monitor. So this particular 3 tasks you can perform: evaluate, test, and monitor. And the data diff, I think. Okay, I think data diff is somewhere they have mentioned. See, it is also integrated like GNAI. So then GNAI also you can perform with the help of evidently AI. So with the help of this particular evidently AI, you can also evaluate your RAG based application, okay, or your LLM based application. You can also monitor that particular LLM based application. So going forward, whenever we'll be discussing about the generative AI, we'll be creating a generative AI project. I'll be also showing you how we can integrate this particular evidently AI with the generative AI project as well. Okay. But as of now, we'll be doing the data diff one only. Okay, data diff we'll be doing. So yeah. So I was exploring this particular tool. Then I just created a Jupyter notebook file, guys, for you. So let me just show you the code snippet, like how we are going to detect this particular data diff. So I'm going to open up this particular file. And here, first of all, what I have to do, first of all, I'll be importing some of the libraries here. Okay, so let's import some of the libraries. So here I can write import pandas as PD. That means, first of all, I have to load my data. Okay, I have to load my data. But as a demo, actually, I'm not going to use my visa data. I'll use one very common data set, which is nothing but Boston house price prediction data, because everyone familiar with this particular data. So with the help of this particular data, I will show you the demo. Then the same demo I'll be applying inside my US visa data. Okay, whenever we'll be doing the data validation, there actually will be applying as a modular coding. Okay, so first of all, let's try to see the experiment, how it can be done. Then I need another actually function from evidently. So first of all, let me write from evidently. So inside that, there is a method you will get called dashboard. And here I need to import one class called dashboard. Okay, this is the class I need to import. Then I also need something called dot evidently. Okay, evidently dot tabs import. I need something called data diff tab. Okay, data diff tab. So if you have the like data, like numerical data, what you can do, you can use this particular method called data diff tab. Okay, with the help of that, you can detect that particular data diff. Okay, in a numerical variable. And for categorical variable, you can use this particular method called data target diff tab. Okay, data target diff tab. This particular method you can use. Now I need to import some more additional package here. So let me just write evidently dot model. Okay, model profile import profile. So with the help of this particular profile, I'm going to create the dashboard, the HTML dashboard. It will give you one HTML file. That particular HTML file you have to render in your browser. Then you will be able to see that particular dashboard. Okay. Then I also need something called evidently dot profile profile sections import data diff profile section. Okay, data diff profile section. This particular method I need. Now let me import all of them. So it should execute properly, guys. You can see there is no error. That means it's working fine. So first of all, let's load our Boston data. So here I can write load our Boston data. Okay, so here I can write Boston data. So how to load the Boston data, guys? So for this, what you can do, you can define one data URL. So data underscore URL. And there is a URL of the Boston data, guys. Let me show you this particular URL. If you don't know, so there is a GitHub URL is available for the Boston data. Okay, you can see that particular URL. So this is the Boston housing data, and this is a CSV file. This is a CSV file, and it is hosted in the GitHub. So I can access this particular data with the help of pandas. So I'll copy this particular link, and I will go back to my code editor. And here I'm just going to write data URL is equal to this particular URL. Okay, then I'm going to use the pandas to read it. So I'll just write pd.read CSV. Inside that I need to pass my data URL. And this is going to give me my data object, so I can store as a Boston. Okay, Boston underscore frame. That means this is the data frame is equal to this is my data frame. Okay, now let me import this particular data. Now if you want to visualize this particular data, simply you can do the head operation on top of this particular data. So I can write Boston frame dot head, and you can see this particular head of the data. That means all of the column it is visible. Okay, whatever data actually you can see that particular server, it is already available inside my local machine right now. Okay, now you can also print the description of the data. For this, again, you can write bostonframe.info. So it will give you the complete description of your data, like how many columns you are having, how much size actually it took in the memory, And what is the data type? You can see these are the floating data type, integer data type. Okay, and there is any null value or not. Okay, everything you will be able to see, and all the column names actually it will list down here. All right, so this is the actually simple statistics actually will get if you apply this particular info method on top of your data frame. Okay, now we'll be just doing the data div. Okay, data div dashboard. That means we'll plot the data div dashboard. So let me do it. So first of all, let's check the shape of my data. So boston.shape here I can do. So here I can see I'm having 506 rows. I'm having 506 rows and I'm having 14 columns here. You can see 506 rows and 14 columns. All right. Now, first of all, what I have to do? I have to say, excuse me. First of all, I have to separate out my training example and I have to separate out my testing example. So what I told you, you can see here, this is my entire data. That means this is my population. Now, what I have to do? I have to do the 10 test split. Okay. Then after doing the 10 test split, what I can do? I can use my, after doing the 10 test split, what I will get my training example as well as my testing example. So the same thing I have to perform. That means this is my complete population. Booston_fame, this is my complete population. It is having 506 records in this particular population. Now I will do the 10 test split. So how I can do it? I can manually do the 10 test split. I can just simply write Boston fame and I want to take first 200 example for the training. First 200 example for the training. Now if I execute, see, it will give me 200 example for the training. Okay. Now if I want to take the testing, so what I can do? I can take last 200. That means after 200, whatever data actually I am having, I can store as a testing data. So here I can write 200 like that. Okay. Now you can see after 200 till 306 actually rows, I got the entire data. That means this is going to be my training data. Here I can write this is going to be my training data. Okay, this is my training data. That means this is my reference data. Reference data. Okay, and this is my test data. Okay, that means my actually sample data. Okay, sample data actually I got it. Now that's how actually we can perform this particular 10 test split. Now what I have to do, I have to create this particular dashboard. So to create a dashboard, I'll import this particular dashboard method. I think you remember I imported here. So dashboard I'm importing. Now inside that I'm going to pass my data. Okay, I have to pass my data, but before that I have to initialize one tabs here. So these are the syntax from the evidently.ai. Okay, this is not my syntax. They're telling if you want to detect the data diff, you have to write the syntax in that way. Okay, now inside that you have to pass this particular parameter called data diff tab. I think you remember we imported previously this particular function. Okay, that's why I'm passing it here. Now it will give you one object. So the object name should be Boston underscore data underscore diff. Okay, data underscore diff underscore dashboard. Okay, this is going to be the variable name. I think it is fine. Underscore, yeah, everything is fine. Now let me execute. See, it's working fine. Now what I have to do, I have to calculate this particular data diff. That means I have to detect that particular data diff. Okay, for this what I can do, I can call this particular object and there is a method called calculate. Okay, inside that you have to pass your data like that. So first of all I have to pass my training sample. So this is the training sample and here I'm going to pass my training sample. Okay, then I'm going to pass my testing sample. So this is going to be my testing sample. Okay, testing sample. So once it is done, now let me execute this particular code. See, my object has created. Now if you want to show this particular dashboard, so what you can do, you can just write this particular code snippet, boostonData.diff, and there is a method called show. Okay, show you can use. Now it will take some time, guys, to render inside your VS Code, but if you don't want to wait, what you can do, you can also save it as a HTML file. So for this what you can do, you can again call this particular object and there is a method called save. Okay, inside that you can mention the file. So let's say this is the file. I can name this particular file Boston. Okay, Boston underscore data underscore drift. Okay, data drift underscore report. Okay, .html. So you have to save as a HTML, not any other file format. Okay, now if I execute, you will see that inside my notebook folder, one HTML file is created. Inside my notebook folder, one HTML file is created. Now I'm going to open up this particular file. I'll go back to the notebook. And if I double click on this particular file, okay, we'll see it will open up one dashboard for me. Okay, see, it will open up one dashboard for me. So this is the complete dashboard. I think, guys, this particular dashboard is visible to all of you. Let me know. This is a complete amazing dashboard, guys, I have created, okay, with the help of evidently.ai. Thanks, Vappy, for the NVIDIA video. Thank you, Pankaj. Apart from evidently, which MLOps tool we are going to use for in this particular playlist? See, we're starting with the a simple project implementation. So here only we'll be using this particular evidently, and deployment wise I'll be using GitHub Action and Docker and all. Going forward, whatever project actually we'll be doing, we'll be using some more advanced tool, like we can use, let's say Jenkins. Okay, we can use Circle CI. We'll be also exploring the Kubernetes. Okay, we'll be also exploring Bento ML, Amazon SageMaker. Okay, different things we'll be exploring, Pankaj. Okay, sorry, I think he's asking this particular question. Navneet, what is the model training, sir? Model training as of now we haven't done. Model training will be doing after doing the data transformation stage. Okay, it's just a data validation stage we are doing right now. All right, so now you can see this is the dashboard, guys, I got, and in this particular dashboard I'm having all the features. Okay, all the features you can see here, all the features you can see in this particular data. Okay, all the features are available. Okay, and you can see the type of this particular features, whether it's a number, whether it's a category, everything would be visible here. All right, now you can see the reference distribution and you can see the current distribution. Now what is a reference distribution, guys? I already told you reference distribution is nothing but your training sample. Okay, your training sample. That means the entire population. Okay, that means the entire population. Okay, and what is this particular current distribution? Current distribution is nothing but your testing sample. Okay, that means your test data. Now you can see both distribution it has plotted. Now you can see your reference distribution as well as the current distribution. Now you can see it is almost same distribution. Okay, it is almost same distribution. Okay, there is no change, small minor change, but minor change actually we don't detect. Okay, you can see if this particular data drift score is close to 1, that means there is no data drift detection. If it is close to 0, that means there is a data drift detection. You can see that there is no detected. Okay, there is no detected. That means this particular distribution and this particular distribution are almost matching. That's why it's not detected. There is no data drift in this particular column. Okay, in the edge column, and you can see the score of that particular data drift. It's almost 64%. Okay, 64% actually confident this particular distribution are same. Data validation means output of the test data. No, data validation means we are validating the data whether my data is in the correct format or not. Let's say whether my data is having all the features, all the, let's say, numbers or not, or it is having any kinds of data drift or not. If none, what I have to do, I have to make my status as true. That means my data set is fine, I can do the training. Otherwise I have to make as a false. See, in machine learning, here you are not using the complete CSV data. Just try to consider Arashu. You are not using the complete US visa CSV data. Okay, we don't take the complete CSV data and we don't train the model. What we do the 10-test split operation. The experiment I showed you, so there actually I was taking the data from my population only here. Okay, the population only. But here what I have done, I have taken two kinds of data, training and testing. That's why this training would be considered as a population right now. Okay, I hope this part is clear. Right? So you have to consider training is your population. That means your reference data, and testing your current data. Okay. I won't say it's a population, it's a reference data. Okay, you have to say reference data inside evidently. All right, that's why it is telling, you can see, if I open up this particular dashboard, it's a reference distribution, it's a current distribution. All right. Yes. Now for the next column, you can see almost this particular distribution are same, again not detected, and this is the score. And for the next column, you can see again it is almost same. There is no detection, not detected. Okay. Again, this is the score. Okay. Now you can also expand this particular things, and you can also try to understand with different graphs. So you can also visualize this particular data distribution, and you can see your current distribution as well as the reference distribution. Okay, it's almost same. Okay, almost same. You can see the percentage, everything you can see, and you can hover it. You can hover your mouse. You can see the interactive dashboard, guys. Okay, interactive dashboard. Okay, that's how you can see for all the columns. Okay, all the columns it is visible. Okay, you can see that. So this is one of the amazing tool they have developed. And if we don't have this particular tool, what I have to do, I have to write this particular code manually, right? So that's why I told you MLOps is nothing but it's a tool actually. At the end, it's a tool. It will make your task automated. Okay, most of the time. Yeah, there is no, see, there is detected also. You can see there are so many data. It is detected as a data drift. Okay, you can see now first 3 column there is no detected, but after 4 column you can see there is a detection. So you can see this particular distribution, these particular distributions are different. That's why it's a detected. That means there is a data drift, and you can see this particular value is close to 0. Okay, very good. I think you understand, right? Now again it's a detected. This particular distribution are not matching. Again detected, 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 detected. Okay. Now I can go to the next page, and here you can also see there is also detection. Okay, that means only 3 column there is no detection. Rest of the columns are in a data drift. You can see data drift detected for 78% of the features. Like 11 out of 14 data set drift is detected. Okay, so it will give you the entire like analytics. Okay, it will give you the entire analytics, and you can see that particular analytics as a visual understanding. But I don't want to plot this at the value. I mean graph. Whenever I will do the pipeline, that means the modular coding, I have to consider this particular number. I have to consider this particular number and this particular data drift detection status. Okay, with the help of that, I can consider whether this particular data set is having data drift or not. Okay, I'll tell you how to do it, write this particular code snippet as well. Okay, so I hope guys this part is clear. All of you, let me know. So we'll follow the same technique to detect the data drift inside our ES visa project as well. This is the idea. All right, so now let's start with our next agenda, which is nothing but data validation. Okay, data validation, because data drift demo I already showed you. That's how we have to detect the data drift. Now you can pick up any kinds of data and you can use the evidently, and you can plot this particular distribution, and you can check the data drift like detection. Okay, now to explain this particular actually data validation, first of all I'm going to show you one flowchart. So let me open up this one flowchart. So this is the flowchart is available inside flowchart folder. Even I will also share with you. I will commit this particular changes in my GitHub. You will get the changes here. Now guys, you can see this is the flowchart. I think I can make a bigger screen. See, this is the flowchart. Now in this particular flowchart, again you can see I have taken some of the constant. Okay, I have taken some of the constant and configuration. So my data validation will run. First of all, what it will do, guys, it will take the train and test from where? From the data ingestion artifact, because I think you remember. So yesterday I was running my data ingestion and I was returning this particular train and test data as my artifact for the next entity, right? Artifact from my next entity. Okay, so that's why you can see data ingestion artifact will return train and test. This particular train and test I have to receive inside my data validation. I have to read the data. Then I have to first of all validate the column. I have to validate the columns, whether I'm having all the columns or not inside my data. I'll first of all validate whether all the columns are having inside my data or not. Okay, I'll just try to match case ID, continent, education, employee, has job experience. I'll match all the column. All the columns are available or not. If it is available, okay, if it is available, my status would be, okay, status would be, you can see here, train status, test status should be false. Columns are missing, data frame. I think here I have written, yeah, you can see here. So if it is a false, so what will happen? If this status is false, it will give you one validation error. If this particular status is false, it will give you the validation error. Otherwise, if it is true, okay, if it is true, you can see if it is true, that means one line I'm bringing here, because it's a flowchart, you can design in any way. So that's how actually I have designed. If it is true, then your data set would be data drift would be detected. That means first of all, I have to validate the columns, whether my number of columns are matching or not. Then I have to check if numerical column exists or not. I think you remember in the data set, we are having some numerical columns. You can see we are having some numerical columns. Let's say this is the numerical columns. This is the numerical columns. This is a numerical columns. These are the numerical column exist or not inside my data set. It is, if it is not exist, again, it would be the validation error. Otherwise, it would be, it will go inside my data drift detection phase. Okay. Then I have to check another actually like a layer, which is nothing but is categorical column exist or not. Again, you can see inside this particular data, I'm also having some categorical data. Okay, I'll also validate this particular categorical data exist or not. If it is not exist, validation error, otherwise it will go to the data diff detection part. Now if my 3 stages run successfully, if this particular 3 stages run successfully, that means validate number of columns, is numerical column exist, and is categorical column exist. If all the status is true, then it will go to my data diff detection phase, and then I will start my data diff detection. That means the evidently like code I will execute, that particular evidently functionality I will be execute on top of the US visa data, and this particular data diff will give you one report. It will give you one report whether it is having data diff or not. If it is having data diff, if yes, okay, if it is having data diff, if yes, so it will again do the validation error. Otherwise what it will show you, if it is a false, it will give you the output. It will give you this particular report. Okay, it will give you this particular report. You can see I will get one report.yaml file. In that particular YAML file, I'll see that particular report. Okay, whether it is a true or false. Okay, then as an artifact, actually it will return these are the path: validation status, validation train file path, test file path. Okay, so it will give you this particular actually status. That means this particular output for the next component, which is nothing but my data transformation. For data transformation, what I need validation status, whether this status is true or not. So let's say how things are working. Let's say this is my data validation component, validation, data validation, data validation. So as an artifact, it will give you output validation status, validation status. Okay, status. If this particular status is true, what I have to do, I have to start my next component, which is nothing but my data transformation, data transformation, data transformation I have to start. Okay, if it is false, what I have to do, I have to raise the error. I have to raise the error, or I have to raise the exception. Okay, exception to the user, your data is not in a correct format. This is the idea. Okay, this is what actually we usually do inside our data validation. Okay, data validation. I hope this part is clear, guys, all of you. Right, now let's try to implement this particular flowchart as my code. So I'll go back to my code editor. Okay, so here what I can do, guys, I can just yeah, close this particular notebooks. It's not required. Yeah, so the same way I'll be updating my file, guys. I think yesterday I told you, first of all I have to update my constant, then entity, then component, then pipeline, then my main file. Okay, main file. Okay, main file, that means my endpoint. Because see, if there is a data diff, so do you really think you have to perform the transformation? Because there is an issue with your data, so you can't use this particular data now. So that's why you have to check the data diff, because after transformation your model trainer will start now. That's why it's just a pipeline, it's a execution of flow. Just try to remember: data ingestion, validation, transformation, trainer, evaluation, pusher. So if one of the stages is failing, okay, it will give you the exception. It won't be running the next pipeline. Okay, that time. That's the idea. Are you sure, right? Yeah. So first of all, I have to update my constant. So let's open up this particular constant folder, and there is a constant file I'm having. So inside that, I'm going to mention my data validation related constant. Okay, so let's mention. So what I can do, yeah, I can mention some additional file as well. So let me just mention quickly. Sorry, I just need to mention additional variable. Okay, let's say target column is my case status. I think you saw inside that particular notebook. Case status is my target column. Current year I need, because I need to calculate the age of the company. Okay, that's why I'm taking this particular current year. Pre-processing object file name. That means whenever you have to save this your like pre-processing object, that means that particular pipeline object you have to save as a pre-processing.pickle. Okay, these are the very common steps inside machine learning. I think you know that. Okay, that's why we are setting these are the variable inside the constant. Now anything else I need to set? Let me just check. We have set the MongoDB URL, train file name, test file name. It is fine. ES visit is fine. Model.pkl we have also added, and we have also added the ES visa.csv, which is available. ES visa CSV, it's also available. Now we also need to add the schema file path URL. Okay, so this is going to be my schema file path URL. So inside actually config, we are having a file, I think you see, schema.yaml. Inside that I have to mention the schema. That means my data schema. So let me show you how your schema will look like. So I already prepared this particular schema. You can see this is the schema. That means number of columns we are having in this particular data set. You can see case ID, continent, education, has jobs, experience, required job training, number of employees. That means whatever things you can see in the data, everything I have mentioned here. Everything I have mentioned here, okay, in this particular schema. Then I mentioned the numerical column, like how many numerical column we are having. So you can see we are having 1, 2, 3, 3 numerical columns. So 1, 2, 3. Then I have mentioned my categorical column. How many categorical column we are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, these are my categorical column. And what are the columns I have to drop? I have to drop the case ID and year of established. I think whenever I did the exploited data analysis, I think you saw that this particular 2 columns is not required. I can remove it. That's why I written inside drop column section. Okay, drop column section I have written. Now here I have written number of features. Okay, for the data transformation, like what are the like transformation we have to apply on top of which are the column. Here I have mentioned. Now ordinal encoding column. You can see these are the column I have to apply the ordinal encoding. Then one-word encoding. These are the column I have to apply the one-word encoding, and transform column, the scaling column. That means the power transformation I have to do on top of this particular column. So everything I have done inside my EDA, whatever things I have done inside my EDA and inside my feature engineering. So here I'm mentioning all of the column, and this is called actually schema. Okay, this is called actually schema. Okay, I hope you got it. Fine, this is called actually schema. So that's how actually you have to prepare the entire schema of your data set. Okay, you have to prepare your schema, okay, inside this particular file. Whether it can be any kinds of data. First of all, try to see the columns, all the columns, try to mention, try to separate out the numerical column, categorical column, that column you have to drop, number of numerical features. Okay, numerical features, like you want to do the transformation, whatever, let's say you are performing in the transformation, let's say one-word encoding, ordinal encoding, power transformation, you can mention in a section. Okay, in a mention in a key value section. So this is a YAML file syntax. Actually you can write this is a key, this is the value. And then YAML file is a dictionary. Okay, if you just read this particular YAML file, it will give you dictionary kinds of output. All right, this is the idea. So that's how actually we have to prepare the schema. Fine, so I think anything is required. Let me check. Schema I have added. Okay, I think there is nothing. Now I can mention my data validation related constant. Here is my data validation related constant, guys. Okay, you can see. So I think you remember we need my data path. So here I'm passing my data validation folder, data diff report and report.yaml. That means whatever things it will generate, everything I'm keeping it here. A data diff report. Then all the things I don't need, you can delete it. I only just need this particular 3 things. Like data validation, that means in the artifact folder, it will create a timestamp. Inside that, it will create a data validation folder. Inside that, it will generate this particular report.yaml. Okay, inside this particular data diff report folder. That is the idea. Whenever I execute the code, it would be more clear. As of now, let's try to save this particular code. Fine. So now what I can do, I have updated my constant. Now I have to update my entity. Okay, so let's update the entity. So I will open up this particular entity folder right now. So here is the config entity as well as my artifact entity. Both I have to update. So again, it's just a like a return of path with the help of os.path.join. You can return your path. So let me just quickly show you. So first of all, I have to update my config entity. So here is my config entity. So again, I'm returning the path with the help of operating system package. So here I can write. Okay, so this is the artifact entity I have written. Sorry guys, I have to save it. Now I can copy this particular entire code, and inside config entity I have to mention. Okay, again you can see I'm returning the path only, my data validation directory path and data diff report file path. Okay, now similar wise I have to update my artifact entity. So again You can see this is my artifact. That means whatever things it will return as an artifact. Okay, after doing the data validation, so it will return validation status. It should be the Boolean type, whether it's a true or false. Then masses, okay, whether it is having the data diff or not, and the data diff report file path. Okay, like that a particular YAML file path it will generate inside my artifact. This particular path would be given for the next component. Next component will load this particular path and will try to understand whether it is having some data diff problem or not. That means the validation status is true or not. If it is true, it will run your data transformation. Otherwise, it will raise the exception. That is the idea. Now let me save. I'll also save this particular file. Now I have to update the component. So now let's go back to the component data validation, and inside that let me update the particular component. So data validation. So again, see, it's a simple logic I have written. First of all, I'm importing all of the necessary library I need. Then I've defined a class called data validation. You can see data validation. It will take the data ingestion artifact as well as the data validation configuration. Inside that, I'm writing the class variable. Okay. Then I've written one particular method. You can see this particular method I've written, validate number of columns. Validate number of columns. It will validate all the columns. So for this, what I'm doing, guys, I'm first of all loading this particular data frame. I'm reading all the columns, and I'm also loading this particular. Schema.yaml file, and from here also I can checking all the number of columns are exist or not. Okay, that is what actually it is happening inside that. Now once it is done, I'm checking is column exist or not, all the column exist or not. You can see that with the help of this particular function, I think I'm calling it somewhere. Just a minute. Here I'm calling it, and this is the next function, is column exist or not, like all the column exist or not in that particular report file. You can see in that particular schema.yaml file, I'm checking whether all the columns are exist or not. Again, it's a simple Python logic, guys. Here I'm just writing a for loop. I'm taking all the numerical column. Okay, you can see I'm taking all the numerical column, all the categorical column. Okay, and I'm checking one by one all the columns are exist or not. If exist, what I have to doing, guys, I'm just sending the status. Okay, I'm just sending the status, it's true, otherwise it's a false. Then again, you can see after writing this particular code snippet, that means this particular things is done. Also this particular things is done. See, these two things actually I'm doing in one function only. In one function I'm doing is column exist or not. Here I'm checking my numerical column and categorical column both. Numerical column and categorical column both. Okay, don't be confused, guys. If you see this particular function carefully, first of all, I'm checking the numerical column, then I'm checking the categorical column. Okay, then after that, I'm starting with my data diff detection. And if you open that particular data diff notebook, the same code I have written here. Okay, I just replicated here as in a modular coding. You can see profile selection, calculate, then I'm saving as a JSON. Okay, these particular things I think I haven't showed you how to save as a JSON format. So let me show you. So let's say instead of saving inside a HTML, I can also save as a JSON format. It is also possible. Okay, how to do it? Let me show you. So for this, what you can do, you can just simply write this particular code snippet. First of all, I'll reinitiate this particular profile. Okay, profile is not defined. So, okay, I think I have to execute this particular code again. Then I have to calculate. Then I have to save as a JSON. So, yeah, this is the code. Now you can see this is the JSON output I'm getting. Like all this code, everything you can see here. Okay, everything you can see here, detected, non-detected, is code, everything I'm getting as a JSON format. Because here I'm writing the modular coding, so I don't need to plot this particular graph. So by seeing this particular number, by seeing this particular activity, I can do it. Okay, whether there is a data diff or not. You can see data diff detected true. Data diff detected true. Okay, so with the help of this particular value, I'll try to detect, okay, whether it is having some data diff problem or not. So that's why we have written this particular function. You can see here this particular function. So you can see I'm taking the metric in data diff features, checking the data diff detection. If you can see the status actually I'm sending, then inside initiate data validation, I'm calling all the function by one. First of all, validate column, then is column exist or not, Then I'm doing the data diff detection. And finally, the output I'm getting, you can see data diff not detected, detected. So this is the error message actually I'm printing, whether it's a true or false. Okay, whether it's a true or false. If it is true, I'm sending as a true, otherwise I'm sending as a false, because I need this particular statement for the next component. Okay, just simply try to understand. See what is happening here. This is your data validation. After validating the data, it will first of all validate the columns, then it will do the data diff detection. If this particular statement is true, that means there is a issue with your data. If your column is not matching, if there is a data diff, it will give you a false. Okay, false message. False means your data, there is some issue with your data. There is some issue with your data validation. That time you have to raise the exception. And if it is true, that means there is no data validation. Sorry, there is no problem with your data. Okay, that is what actually I'm doing in this particular code snippet. Okay, if you see it carefully, I'm doing the same thing. Now let's test this particular code, whether it's working or not. I can save and I can now update my pipeline. So to update the pipeline, I will open this particular pipeline folder, my training pipeline. And here I have to first of all import, your packages. Okay, so let me import quickly. First of all, I have to import data validation. Then I need to import data validation config. Data validation config. Then I also need to import something called data validation artifact. Okay. Then I also need to initialize my data validation config inside my training pipeline. Then I have to start the data validation. So for this, I'm going to write a function. Start data validation. And again, I'm calling this particular initiate data validation from my data validation itself. Okay. If I execute this particular method, everything would be executed. Okay. That is what actually I'm doing. The same thing we did for the data ingestion as well. Then now I have to call this particular method inside my run pipeline. So here I'll be calling this particular method inside my run pipeline. After data ingestion, your data validation will execute. Okay. This is the flow of execution I'm handling here. Now I think everything is fine. Now I can open up my demo.py and run pipeline is calling here. Now let me execute the code. So I'll open up my terminal. I'll clear it. Now see guys, this is my artifact as of now. Now if I execute this particular code again, so python demo.py. Now again it will ingest the data. Okay, so it should throw one error because I haven't set my environment variable. Let me check whether it is available or not. I think yesterday, remember, we set our environment variable, so it should be there. MongoDB URL, I think it is there. Let's see whether it is able to load or not. Otherwise, we'll set manually. Okay, I think execution successfully. That means it is able to take that particular credential from my environment, and this is the execution, guys. And you can see the previous execution only data ingestion was there. Now the last execution, you can see data ingestion as well as the validation is also available. Data ingestion wise, it has stored all of my data, okay, from my database, and data validation, I got one report. You can see I got one report, and this is the complete report, guys. I got. You can see this is the complete data diff report. It's like very big, so it's not understandable like that. Okay, so from here I only need to take the true false statement. Okay, now if you want to take understand whether it is having data diff or not, what you can do, you can open up this particular log file. So there is a log file. This is my log file, and if I go last, so there is a data diff. Data diff to see message is data diff not detected. Okay, data diff not detected, and validation status is true. That means there is no issue with my data. Sorry, I think I told you wrong. If it is true, that means there is no issue. If it is false, that means there is the issue. Okay, and you can see this particular message, diff not detected. Diff not detected. Okay, that means the data we are using, this particular US visa data, there is no issue with this particular data diff problem. Okay, I hope you got it. That's how we can do the data diff detection, guys. See, only one particular column has detected as my data diff, which is nothing but this particular column. I think you remember which column I'm talking about, guys. That particular case ID, right? I think you remember the case ID column, which is having unique value, right? So this particular column has detected as my data diff. But again, it's a majority calculation. If 1 and 2 or 3 column is detecting as a data diff, it won't be considered. If your majority columns are having actually not data diff, it would be considered as a 2. Okay, otherwise it would be considered as a false. I hope this part is clear, guys. Fine. So this is what actually we can do the data validation part. Now let me give you the source code. So I can just push this particular code. So here I can write data validation added. Will you use Kubernetes in this project? No. In other project, we'll be using Kubernetes, Suraj. Now, please try to execute from your end, guys, once, and you can let me know whether it is executing fine or not from your side. And this part would be much clear, okay, that time. If you are executing from your end. See, code is available. Everything I've shared, only you just need to execute from your end, okay? Yes. So next class, guys, we'll be starting with the transformation, data transformation. In the transformation, we'll be doing all the feature engineering tasks we have done in the notebook. Okay. Then after that, we'll train the model, we'll evaluate the model, and we'll push the model to the S3 bucket. Then once my model push and everything is completed, I'll create the web application of my entire application. Okay. Then we'll try to deployment this particular project over the cloud platform. This is the entire idea. So in case after production, how we'll calculate the data diff for the new data, they will consider the previous training data as a reference. No, see, in production also, let's say whenever you are hosting this particular application, right? So again, if your new data is coming, that means whenever you are having this particular data, whenever you are having this particular model in the, let's say, production server, there also you need to train the model, right? And whenever you are training the model, that means you are executing data ingestion, validation, transformation, everything. That time you can see whether it is having data diff or not. If data diff up there, you have to fix it. Otherwise, you can use that particular model. Okay. And in future, if your data source is changing, again, you have to return that particular model. Okay. You have to return this particular entire project again. Okay. That is what actually you have to do. Which test is used to calculate the data diff score? Please explain those columns in evidently. So there are some statistical column is used. You can see start test K, KS and P value. I am familiar with P value, but I am not familiar with the KS parameter. Maybe those who knows statistics better than me, they can tell, okay, what is K value, KS parameter. But I think you know the P value, right? P value is statistics. So this is actually P value calculation actually at the end. Sir, if diff detected, resampling is manual or what is the process? First of all, do the resampling. If not working, try to increase the data, Praveen. Okay, that's the idea. And try to take the data from the same population always. Not from any other population. I think I told you, na? There is a dog cat example I have given. Let's say we are using dog images for the training. No need to take any cat images for the testing. So whenever training the model, try to take the dog images as well as the cat images. Both images you have to take. Okay, then you will be able to do the testing operation on top of it. That's the idea. I hope this part is clear. Okay, guys. So now, if you like this particular session, guys, so please try to like this particular video and try to subscribe to my channel as well if you haven't subscribed yet. Because so many people are watching, but they are not getting subscribed to my channel. Okay, let's hit 12,000 subscribers, guys, as soon as possible. Okay, so that I can bring lots of content for you, lots of new actually content for you in future, right? All right. So yes, guys, this is all for today's actually session. Tomorrow, actually, I'll be doing the transformation part and the model training part.
and we'll try to see like how to do the transformation in a modular way and how to do the model training and all, everything we'll try to see. And once we complete this particular project, we'll do the deployment, okay, of this particular project. And please try to see this, the complete playlist. So here actually I have added all the video and resources is also available. Let me share the resources again in the chat. Yeah. So yes, guys, this is all from today's session. So I think you like this particular session. So thank you so much, guys, for joining this particular session. Bye, everyone. Take care. Bye. Thank you.